Hello everyone, welcome to the lab. Look what I've got. These Fluke scope meters multiply like rabbits here. In one of my previous videos I tried repairing this unit, which is model 196C, 100 MHz, 1 gigasample per second, and I was not successful. The channel A in this unit is faulty, and I believe that the channel ASIC is dead. And by the way, I asked Fluke tech support if they had that chip, and they got back to me quoting about $180 for the ASIC. Well, I am glad that they respond and that they have stock, but this price is not quite practical, at least for me. I believe for this money one should be able to find a parts unit on eBay or something like that, which I did. I ended up buying these two units, and this is a better model, 199C, 200 MHz, 2.5 gigasamples per second, and this is the same model. I bought these two units from the same seller, and they turned out to be seriously incomplete, especially this one. And most probably the seller didn't even know, because they seem to be in the business of reselling surplus equipment from big companies after some upgrades or closures or something like that, as I understand. So I have already taken them apart to check them out because I needed to make a decision whether to return them or keep them and negotiate some discount or something like that. So I ended up paying about $180 for this unit. And most probably both channel ASICs are good here, and there are many more other parts. So I don't think it's a bad deal at all. And I ended up paying slightly more than $300 for this unit, which is also incomplete, but it is almost working, and it is very promising. Let's have a closer look. Both units were sold with no accessories whatsoever, no probes and no power supplies, nothing at all, and batteries are missing in both units. And as I said, this unit is quite promising, and I have done a small repair to it already. I can show it later. So I connected the power, and look at this. It powers up, and by the way, it always powers up with this message about some free bonus, and I have to dismiss it every time. I don't know why this message is here and how to get rid of it forever. So, I've done some basic checking and it seems to work just fine, but it still has some problems. For example, there is a small blemish here on the screen, which is tolerable, not a big deal. And also, as I showed in my previous video, these units have fans inside, and fans are missing in both units. And also, in this unit, the biggest problem with it, in fact, is that the keypad is intermittent. Now it seems to work, and when we powered it up it beeped once, but sometimes when I power it up it beeps twice, and then the keypad is not responsive at all. Let's see. Oh, there you go, 2 beeps, and now I cannot even dismiss this message anymore. So, I believe this unit needs a battery, it needs a fan, and most importantly, it needs this keypad foil, as Fluke calls it in the service manual. It seems to me that the keypad behaves as if some keys are pressed all the time, in particular this user key. If this key is pressed when the unit is powered up, it's supposed to beep twice and reset to the default settings. So at least this key appears to be pressed all the time. And the keypad foil is missing in this unit altogether, And some other parts are missing as well, so I cannot even try powering this up right now. So let me take them apart and show you. Here is the second unit taken apart. There are many problems here. First of all, memory module is missing here, and that's a big one. Then power connector is missing, and that's an unusual connector with a plastic hook which should go into the slot in the board, and with a rubber gasket which should make it waterproof, so might not be very easy to find the replacement. Then, as I said, the fan is missing here, and the keypad foil is missing. And I tried borrowing the keypad foil from a working unit, the one I tried to repair in the previous video, and the memory module from the other unit, which is the same model. The keypad did not work anyway, so I had to power this thing up by shorting one of the test points to the ground. So it does power up, and the channel A appears to work, but I couldn't test it beyond that because of non-working keypad. And I tried tracing connections from these test points to the keys, and the connections are missing, at least some of them. So it seems to me that something is wrong with this connector. And if so, this is not a big problem, because these are through-hole connectors, and I found them on DigiKey and Mouser for about 40 cents a piece. But that's not all. There is a problem with this display. There is this mark on it, and sure enough, it has a defect. I'm not sure if it's visible. There is a spot here. Maybe it can be tolerated, but it's a big and ugly spot. Much uglier than in the previous unit I showed. And also there are cracks in these standoffs for the screws, which should hold this display in place. And finally, there's a small chip in this BNC connector. So clearly this is an incomplete collection of bad parts. Now let's focus on the unit which is promising. I took it apart to show you a repair I have done to it already. And as I mentioned, the fan is missing, and as we have seen, the keypad foil is intermittent, and the battery is missing as well. And I have some ideas about the battery, so yet another battery upgrade to lithium-ion video is coming soon, I suppose. And now let me show you the repair. There was a horrible soldering job here around the input connectors. Perhaps someone replaced them. Here is a better view. Someone has done a horrible job soldering these input connectors and left soldering iron marks all over the place. For example, here on the board around the pads and on some components. For example, this capacitor is damaged badly. And there is another mark here on the power connector, and another mark on this capacitor, but not as bad as on that one. And I have already brushed this up. I reflowed soldering joints and cleaned the flux. And sorry, I forgot to take pictures before. Now it looks much better. But most importantly, this ground pin was broken off and missing altogether. And because of that, channel A did not work at all, of course. And there was a small piece sticking out from that BNC connector, and I managed to carefully solder to that small piece and repaired this ground pin, and now channel A seems to work fine. I looked at the schematic and did some checking, and here is what I found. The on-off key is separate from all other keys, and it works by pulling a dedicated pin of the ASIC to the ground. But all other keys are arranged as a 6x6 matrix, and the ground is not involved there at all. However, I found that one of the lines here is shorted to the ground inside of this foil somewhere. And look at this, the lines go right here and to the keypad, but this extra part works as a shield for these display connections, the high voltage backlight and LCD interface. And that's why one of the layers in this foil is filled with ground, and it is only here around the connectors. There is no such fill in the rest of the foil. So apparently somewhere over here there is an internal short to the ground. So the non-working keypad is the biggest problem now with this unit. And here I found a replacement on eBay for $75 with free shipping. And this is not an original Fluke part, but some sort of a board which replaces foil. And the seller is a bit vague about what this thing is. There is no full picture of it. And I think this is deliberate to avoid giving away a secret know-how. And these things are also available on this website, scopemeterrepair.com. They have basic calibration and channel repair. Look at this price, $345, but currently unavailable. And they have some other things, batteries, some parts, and here it is, keypad contact board. $65 here, but probably some shipping is involved. And they also have this exotic power connector, also $65. Wow. And again, there is no full picture of this keypad contact board, but I have some idea what this is, and I am going to try making my own. So my idea is to put a very thin PCB here, perhaps 0.4 millimeters or even 0.2 millimeters PCB. But a tricky part is where to put a connector for a flat flex cable without modifying anything, like cutting a hole in this metal plate which supports the keypad. The plate covers almost everything, and there are plastic walls here and here, so the PCB cannot extend this way. But there are two small plastic guides sticking up through two small holes in this foil to align it, and the plate does not cover this part. So here might be just enough room for a vertical connector so that flat flex can run this way, then it can be folded to make a 90-degree turn and then another turn and end up here where the connector is on the main board. There is a small step here. This part is slightly lower than this, and this supporting backplate is bent here a little bit. So I hope that for a very thin board this should not be a problem. Here is the description of the keypad in the service manual, and here they say that it is a row column matrix connected to the DASIC, and on-off key is not included in the matrix. It is directly connected to an input of the DASIC. And here is a table, 6 columns and 6 rows, for some reason flipped. These should be rows and these should be columns, but it doesn't matter. At least I don't have to trace the connections on the foil. Thank you very much. And here it is on the schematic, 15-pin connector. Here is the on key line going to the ASIC, and these are 6 columns going here to the ASIC and the 6 rows going here to the ASIC. And all these lines have test points on the board right next to the connector. And it is easy to turn the unit on and off by shorting this test point to the ground. I'm using KiCad and the schematic is ready. This is the easiest part. And it ended up a bit too crowded, but I'm not going to spend more time moving these keys apart a bit. It's good enough. And here is the hardest part done. And this is a view from the front. So this connector is facing the other way. It is on the back of the board. Let's have a closer look. I decided to use a through-hole connector because SMD equivalent is wider, and this connector is too close to this guiding hole. And by the way, I decided not to put holes in these locations, but only marks on the silk screen, and I'm going to drill myself. Not sure it was the best decision on my part, but I was not comfortable with a hole on this side because it is too close to this connector. Perhaps it would violate some design rules and such. Anyway, I put these crosses on the silk screen, and I'm going to take care of this myself. And let me show you the SMD part. And here it is. I need to rotate it. There you go. You see, it is wider by quite a bit and will interfere with this hole. So a through hole should work better, I believe. And I downloaded footprints for these connectors through DigiKey from Ultra Librarian. And I had to brush them up a little bit, but it was a good start. Thank you very much, DigiKey and Ultra Librarian. Here is a through-hole connector on DigiKey, 42 cents a piece, and here is a link to CAD models. Download from Ultra Librarian. Thank you very much. And here is a flat flex cable on Mouser.com. 15 pin, 1 mm pitch, 100 mm long, exactly what's needed. $1.21 a piece. I looked at several popular PCB manufacturers and I found that PCBWay offers 0.2 mm thick boards. Excellent, that's what I want. And the price is the same as for 0.4. Let's see, the size is 142 by 104 millimeters, 5 pieces, which is the minimum order, 2 layers, and the price is $91. And if I switch to 0.4, it's the same, and it is cheaper for 0.6, $60, and it is the same up to 1.6. Still 60, and it becomes more expensive at 2 mm, 91 again, and even more expensive for 2.4, and so on. So let's go back to 0.2, and I could have more pieces for just slightly more money. For $12 more I can have 5 more pieces, which is tempting. I might sell some of them to offset my cost, but let's not do that. This is the first version. It might have some mistakes and I don't need this many myself, so let's make 5 for now. Now let's look at the fan. Here's a picture of it I took in the working unit, the one I tried to repair in my previous video. Here is the part number and 5 volts, 0.15 watts. And this is the other side of the fan. Unusual metal case, and these 3 sides are blocked. The outlet is only on this side, and I checked, the air flows out of this thing. I wonder how important is this metal case. I'm afraid it's hard to find. And here is the datasheet, 40 by 40 by 9 millimeters. Here it is in the last row, 5 volts, 30 milliamps, 0.15 watts, 4200 RPM, 1.1 cubic feet per minute, 0.12 static pressure, and 20 dBA noise. And here is the closest fan I could find on DigiKey and Mouser. Delta Electronics, 10 millimeters deep, and I think this should be okay. This one has more airflow and is slightly quieter and the same 0.15 watts. And these things are $9.70 a piece. I think this should be good enough. Let's see, how much room do we really have here? Something like this, about 11 millimeters. So with a 10 millimeter fan, we should have about 1 millimeter left for the air to flow, and that looks fine to me. I would think not much airflow is needed here anyway, because these scope meters are completely sealed and even waterproof, no vents at all. So the idea must be just to spread the heat around, absorb into the metal frame and dissipate through the case. The boards have arrived, packaged on a piece of something quite stiff, cut to size. Looks like a piece of plastic to me. Excellent packaging, thank you very much. It seems like this is a piece of MDF used as padding for drilling. And the boards look great. Just a quick check how thick the boards actually are. And by the way, the original thing is about 0.14 millimeter. The guiding holes are drilled about 1.7 millimeters. The connector is soldered. Time to give this a go. It turns out that I should have moved this connector slightly this way. There is some room, a few millimeters here, so it wouldn't interfere with this metal tab on the supporting backplate at all. Currently this tab needs to go under the connector a little bit, and the connector is soldered standing above the board slightly, and it's better to remove the LCD for the installation. So this is not ideal, but should work fine. The next step, here is how it looks with the flat flex cable installed. And it's better to install the flat flex before putting this metal frame back in place. Oops, silly me, made a mistake. Look, if we connect two such connectors with a flat flex, what is pin 1 on this connector becomes pin 15 on this. So this connector should have been mirrored. What a mistake. What can I do about this? Well, perhaps I can solder the connector on the other side. I hope there's enough room there. Alright, soldered the connector on the other side. There is not quite enough room there. It just barely fits, and the board is going to be slightly bent. And the flat flex will take a little more room, but it seems like this might work. This flat flex needs to go around the connector like so, but this rigid piece of plastic does not allow to bend it right at the connector. So I'm thinking about carefully peeling it off from the flat flex, just a little bit for this length of about a couple millimeters or so, and trimming it right here so it wouldn't stick out of the connector. It still needs to be inside of the connector for the right thickness and for making good contacts. So now the flat flex can be bent around the connector just fine. Here it is, installed. The connector just barely fits there, not the way I intended it, but it seems to work. So this metal frame pushes on the edge of this supporting plate, which supports the keypad, and it is screwed down into metal inserts in the plastic here and here, and as you can see, it's screwed down all the way, no problem. Everything seems to fit together just fine. And by the way, because this shielding for the display connectors is gone now, it would be a good idea to arrange something instead. Let's say a white piece of conductive tape attached to this metal shield and going like so, covering this area, or something like that. And look at this. It works. We can dismiss this, we can switch to the meter, back to scope, clear this menu, bring up user menu, clear again, enable cursors, disable, we can go to trigger menu, input A menu, input B menu, we can move this trace down and up. No problem. Hold and run. Everything seems to work fine. I checked all the buttons, so no other mistakes. I'm quite happy about this. Now let's take care of the fan. Here it is. And unfortunately I forgot to order a new connector housing and the crimp contacts, which I could just crimp on the end of this cable. And I already have this crimping tool, and that would look professionally, but I forgot to order, so for now I'm going to use this connector I salvaged from something like a battery pack for an old cordless phone. Here is a Molex connector I'm talking about. The picture here is generic. This is a 2-position connector. Here it is, 2-position, 2.5mm pitch, and they cost 15 cents a piece. And this, I believe, is the right contact for them, but I'm not entirely sure. The price here is for a strip of 100, $5.70, and perhaps they can be bought in smaller quantities, but I'm not sure, I didn't look for that. Probably more expensive a piece, but they are quite cheap anyway. Here it is installed, and unfortunately it turns out that the distance between the holes is slightly different. It's off by about a couple of millimeters. So I attached the fan with just one screw. Not ideal, but should work. And the air flows towards us. Not sure if it's important. I would think that the most important thing here is to move the air around with very low power. This is the second unit, and as I mentioned before, something seems to be wrong with this connector. So now we have this new flat flex. Should be easy to check, and nothing is wrong with the cable, of course. So we have continuity mode here. Let me touch pin 1 here and pin 1 in the connector, and nothing. Pin 2, nothing. Pin 3, oh, pin 3 is fine. Pin 4, nothing. Pin 5, nothing. And so on. Most of the pins don't make contact. I'm not sure how did this happen, and you see it's quite loose. So we need to replace this connector. It should be quite easy to desolder this through-hole connector using my paste desoldering station. I'm not going to show the process. I don't think it's very interesting, and I have shown it before in several videos. The old connector is gone. Let's solder a new one. Alright, the keypad is installed in the second unit. The memory module is borrowed from the other unit. Power connector is improvised for now. And look at this. It works. This is the ugly spot I mentioned before. And look, both channels seem to work on the first glance. This is 1 kilohertz 1 volt peak-to-peak signal from my signal generator on channel A. And let's try the same thing on channel B. Here it is, channel B, and I switched the measurements to channel B as well. Seems to work fine. And this is the memory module, which is missing in one of the units. A couple of flash chips with firmware in them, and a couple of RAM chips. And here is the other side, nothing at all here. So here we are. This unit seems to be fully working. It still needs a battery, but that's a minor problem. And this unit needs a power connector, and the biggest problem is the missing memory module. I wonder if I can make one myself, but I'm not sure if programming firmware into it is easy or not. It might be trivial or it might be very hard. It might take special adapters for a programmer or something like that. If you know anything about this, please let me know in the comments below or on the EEVblog forum. The link will be in the description. And I am so glad that despite of my mistake, these boards are still usable. This is how we learn. Try designing something yourself. Version 1 can happen to be perfect, but not very often. And I am not a professional electronics engineer. I do software. And do you know how many software engineers does it take to change a light bulb? No one. It's a hardware problem. Thanks for watching. Bye.